the last class, we had discussed the timing and control. Okay, so we had seen at the control unit, okay, in particular. So, two types of control units we had discussed. What is a microprogram? How do we go up the hierarchy, starting from micro operation to a micro instruction to a microprogram? We had discussed, right? And then we had uh, discussed the differences between the hardwired and microprogrammed control unit before coming to the block diagram of the hardwired control unit of the basic computer that is presented in our book, in our textbook. And in here we had actually discussed how the control signals are generated and how the timing signals are generated, right? So we had seen this, we had discussed the idea of the timing signals and the control signals, looking at the working of the control unit, right? Now, today we are going to talk about the implementation of the instructions. Okay, so how do the instructions get executed, right? Each instruction passes through a set of phases before it finally gets executed. There are generally four distinguishable phases, namely the fetch phase, wherein we fetch the instruction which is to be executed from the main memory, that is RAM, into the CPU. So inside one of the registers that we had discussed, right? One of the 8 registers. So inside one of the 8 registers, we bring that instruction and we place it there. Which register is that? Let me see if you remember it. Do you remember? Nobody remembers. Hmm? Instruction register. छोड़ दिया पढ़ना लिखना. Everybody is left reading the book. After the fetch phase, we go over to the decode phase. So the instruction which has been fetched from RAM, placed into one of the registers of the CPU, is now decoded. Okay, so we will see how this process of decoding takes place. Now, after this, when we have decoded what operation is to be performed in this instruction, we also look at what is the addressing mode side by side. So in the decode phase itself, we not only decode the operation which is to be performed while implementing, while executing the instruction, we also look at the addressing mode, right? And if the addressing mode is indirect, then what do we need to do? We need to get the effective address of the operand. Now, if the instruction, we already know that if the instruction is direct, okay, then the effective address of the operand on which the operation is to be performed is already present in the address part of the instruction, right? But if the effective mode, I'm sorry, if the addressing mode is indirect, then we know that the address which is present in the address part of the instruction is actually the address of the address of the operand. That means,
Operand.
yes, address of the effective address, right? If address from where I will get the effective address, right? So in that case, this is a extra step. This is a extra step, okay, and it takes one extra clock cycle, the third phase, okay. This is sometimes known as the indirect phase, and in case the addressing mode is indirect, then we have to undergo this phase. So what do we do in this phase? We go and read the effective address from the main memory, okay. And then the final phase is the execution of the instruction, okay. So when I have crossed all these phases, please see, I already have my instruction and I have decoded it. I know now know what is the operation to be performed, what is the where is the operand located, and now I can finally go and execute the instruction. Is this clear? So the fourth and the final phase is the execution.
Execution.
Yes. Now we are going to look at the detailed instruction cycle with the help of this flow chart that you see on your screen. Okay. Every instruction cycle starts with the sequence counter being clear to 0. Okay. So if you remember the sequence counter that you saw here, right? I told you what is the significance of this sequence counter. This sequence counter starts counting from 0, okay, and when it counts 0, the corresponding time signal that is provided is T0. When it counts 0001, assuming it is a 4-bit sequence counter, then the time signal that would be generated would be T1.
T4.
0001, it would be T1.
Yeah, ma'am. T1.
0010, it would be T2, and so on, so forth, right? So initially, when any instruction starts, we start with the time signal T0, and to do that, we need to reset our sequence counter to 0. Is this clear? Is this clear?
Yes, ma'am.
Right. Now, these steps form the part of the fetch phase. Okay, so let us see what micro operations do I need to do to fetch the instruction from main memory in which register? Students, I'm going to, this means that, I'm sending you recordings, and that is why you are not paying enough attention in the class, I think. Are you there, first of all?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
अभी
Yes,
तो
ma'am.
बताया मैंने इंस्ट्रक्शन रजिस्टर बेटा. Don't you know which register we place the instruction in? What is the job of instruction register? What is the job of instruction register?
To hold instruction.
Instructions in it.
Yes. Please be attentive in the class. There is no point in, wailing out your time right now and then later falling back on the recordings, right? I can just record and then send you the recordings, but it will not be interactive. What you can ask me right now, you will not be able to ask me later, right? And even if any teacher has to explain the same thing to you again, the entire narrative, the entire context has to be recreated. Okay, a person is able to understand a particular thing correctly, and sometimes only when the particular narrative is available. Okay, in the context of a given scenario. So, if you were to ask me later, and I were to even oblige to you, I may even tell you, but then, we have to together go through this scenario again. I have to build this entire context again. Clear? Right?
Yes, ma'am.
Yes, ma'am.
So I request you all to be very attentive in the class. Instruction cycle is one of the most important things, okay, that uh, we are going to do. And it is generally asked, this entire cycle, this entire flow chart is asked, and it carries a lot of weightage, okay, sometimes as high as 5 marks, 6 marks, even more than that. Okay, individual phases are asked. Sometimes, they ask you what are the operations or micro instructions which are involved in the fetch phase, right? And I also told you last time that this is what you will be exactly, you know doing in the practical as well. Okay, right? All the more motivation to be mentally present in the class. Okay, but why do you want to waste your time twice? You look at the recording and you can be, either revising the concepts or just, trying to understand them for the very first time. What is more beneficial for you? You're big enough to understand. Okay, yes, are we on the same
Yes,
page?
ma'am.
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Okay,
ma'am.
Yes.
good. Nice to hear so many voices. Okay, so please keep on giving me the feedback. Otherwise, I will start, you know, um putting in exercises where I'll ask you questions. Okay, and you will have to answer. And I'll, base my assessment on that as well. Clear? That would be difficult for you then. ठीक है?
Okay,
Okay,
ma'am.
ma'am.
समझ रहे हैं?
Yes, ma'am. Okay,
Yes,
ma'am.
ma'am. Okay, ma'am.
Ma'am.
Hmm. Okay. So in the fetch phase, the ultimate goal is to get the instruction from the main memory and place it into the instruction register.
Instruction register.
Yeah. So how do we do that? First of all, which register has the address of the next instruction to be executed?
Program counter.
Program counter.
Very good. So, and which register, which register is used to serve as an intermediary with the main memory? That means, what register should I choose? In what register should I put in the address whose contents I want to get from the main memory?
Address register.
Register.
Address register, right? So you have told me yourself, what do I need to do in the time signal T0? So please see, my next instruction to be executed, its address is in the program counter. In the first time signal, that is in the time signal T0, what do? We transfer the address of my instruction from PC to AR,
AR.
AR.
right? This is so that in the next time signal, I go to the memory location at this address. What is the meaning of this symbolic expression? This symbolic expression means memory address at the at the address given by AR. Okay, so I go to this memory location. I go to this memory location, and what is stored there? My instruction is stored there. So I take it and I place it
Instruction register.
in the
Instruction register.
instruction register. Yes, and please see, before I go on to the next time signal, I'm doing another operation here, and that is what? I am incrementing my program counter side by side. Okay, now why is this? This is necessary because if you remember, by definition, program counter at all times must contain the address of the next instruction to be executed. As soon as the instruction which is to be executed is placed in the instruction register, it becomes the current instruction. From the next instruction, now it has become the current instruction. So program counter cannot keep on holding the address of this instruction anymore, right? So it is incremented or a new address is assigned to it. Okay, generally we increment it by one because uh, generally we bring the entire program. What is a program? Program is a set of instructions. So the entire program, okay, depending upon obviously, how long is it. So some programs may be very, very large. That's another scenario. For example, big softwares and all. So only a part of those softwares is copied into the main memory from the hard disk. But whenever we copy certain instructions or data from the hard disk and place them in the main memory, please always remember that as long as we are able to, there is enough space in the memory in the contiguous locations. That means in the in the uh, mm, locations which are located next to each other. Okay, we place the programs, that is the instructions or the data, together. Okay, so generally when we want to go on to the next instruction, it boils down to incrementing the PC by one. Okay,
Yes,
so
ma'am.
I am doing this again. Let us do this again. Okay, so we first of all set our sequence counter to 0 so that the time signal generated is T0, and then I go out looking for the address of my instruction to be next instruction to be executed. I get that in program counter. From the program counter, I need to transfer it to the AR because AR is the register which is designated to
Hold
interface
instruction.
with the main memory, right? So once I transfer the address of the next instruction to AR, and then I transfer the actual instruction into the instruction register, I increment the value which is there in the PC. Why? Because now I want it to start pointing to the next instruction. Okay, okay, as per its definition, right? And why are we incrementing it by one? Because normally all the instructions that we copy from the hard disk, when we bring them into the memory, we generally place them in the contiguous locations. Is this clear to everybody?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Very
Ma'am,
good.
when signal is T0,
Yes,
why
ma'am.
I'm
the
not able to hear you. Who is
ma'am
this?
Dipali?
Yeah, Dipali, tell me.
Ma'am, when time signal is T0, why we transfer contents of PC into AR?
Why are we transferring from PC to AR?
Yes, ma'am.
Because I already told you that the function of AR, AR is the only register which is allowed to, contain the address from which we want to, to which we want to either read or write into the memory. Okay, so if you have to interface with the main memory, you must first put the address in AR. Okay,
Okay,
clear?
ma'am. Yes, ma'am.
So this completes the fetch phase. Next, we come to the decode phase. Now, what do we do in the decode phase? So if you remember the instruction register, yeah, you can see here. So this is the instruction register, right? If you remember, we had reserved the first 12 bits of the register for the address of the operand, the next three for the opcode, and the last one for the addressing mode, right? So in the decode phase, what do? We actually copy this addressing mode into a flip-flop, okay, which is then supplied to the control unit so that it can make sense of what the addressing mode is, whether it is direct or indirect in case of memory reference instruction, or otherwise it does it imply a register reference instruction or a IO instruction, right? You remember all those things, I hope.
Yes, ma'am.
Remember all this code, right? Yes. So memory reference instructions, the opcodes were 0002 111. I'm sorry, 110. Right. If the mode bit was 0, then it was a direct memory reference instruction. If the mode bit was 1, then this was an indirect memory reference instruction, right? Now, a single opcode in our basic computer, this is not to talk about the current architectures, please see, this is only to give you an idea and introduction for the about the architectures. So we are just looking at the basic computer and trying to just understand the absorb the concepts here. So we've reserved only a single opcode, that is 111, for both the register reference and the IO instruction. For the register reference instruction, the mode bit is set to 0, and the mode bit when the mode bit is set to 1, it implies the IO instructions, right? So accordingly, the control unit looks at the these three bits and the 15th bit from the IR register together to make sense of what kind of instruction this is and what do I have to perform. Okay. And as we discussed in the last class, we place a 3 cross 8 decoder here, okay, which actually decodes what op operation is to be performed depending upon what are the values in these three bits. Okay, so if for example the value is uh, 000, then the operation was and, right? Let us see. Yeah. So if the operation was, if the opcode was 000, then the operation was AND. If it was 001, then it was add 0 10 it is LDA, 011 STA, and so on and so forth. Right? Is this clear?
Yes, ma'am.
Yes, ma'am.
So this is the work which is done in the decode phase. Okay. Let us see how do we represent it using the micro instructions. So to repeat, what is a micro operation? Who will tell me? You know, students, what I'm going to do? Next class, I'm going to take a break and sit back. Okay? I keep on talking for the entire hour, right? And you sit quietly. So, next class, I'm just going to reverse the tables and I am going to sit quietly and let you all go on, right? So, I will have a full fledged assessment of yours in the next class. ठीक है ना? मैम को भी एक दिन अच्छे से मिलना चाहिए, आराम से बैठ के. ठीक है? Agreed? Everybody's run off now, I think. Huh? Nobody wants to speak up only. This is going to happen, I'm telling you. The way you people are.
No, ma'am.
No, ma'am, क्या होता है? There is no no, ma'am.
Ma'am, it's okay.
Start reading, okay? Right? Okay.
Okay, ma'am.
So next time I am definitely going to ask you. First, I will ask you the questions from this section and then I will proceed. Okay? ठीक है?
Okay, ma'am.
Okay, ma'am.
Okay, good. So please see how do we, what is a micro operation? Micro operation, micro operation. The name says it all. Okay, the operation which cannot be subdivided any further, or in other words is the very basic operation or the operation which is done at the register level is called the micro operation. Okay, any instruction that specifies a micro operation is called a micro instruction. Hello students.
Yes, ma'am.
Yes,
Yes, ma'am.
Yes, ma'am.
and a set of micro instructions put together forms a
Yes,
micro
ma'am.
Operation.
program. Okay,
Microprogram.
yeah. Hmm. Now a set of, as we will see, you know, we also sometimes say that a set of micro instructions put together form what is known as a machine instruction. Okay, so I will uh, demonstrate what do I mean by this in a while. Okay, first let us just see the micro operations corresponding to the decode phase. So what do? We decode the operation code in the instruction registers, which is present in the bits 12 to 14, right?
14. Yes, ma'am.
12 to 14. Okay, right? By applying a T
Ma'am.
cross 8 decoder here, right? And the 15th bit is transferred into the flip flop I, right? You saw it in the
Yes,
last
ma'am.
class, right?
Yes, ma'am.
And the first 12 bits of the instruction register are transferred where? They are transferred to the address register, because if it is a direct instruction, that these 12 bits would mean that these are the address of the operand, and if it is a indirect instruction, then it would mean that this is these contain the address of the effective address. Is this clear?
Yes, ma'am.
Yes, ma'am.
Now, just give me a second, please. Yeah, sorry, that was an urgent call I had to take from college only regarding the college day. Okay, so okay, now after the decode phase, so this is the only thing that is done in the decode phase. Please also keep on looking at the time signals, and these time signals are going to be very important when you draw them, okay, in the exam. Okay, so please, you know, keep taking notes of the time signals as well. Now after the decode phase, please see, I know whether, you know, what is my opcode, right? Okay, now if this opcode is D7, what is D7? When is D7 active? Please see, D7 will get active when I have 1 1 1 here, right? Is
Yes,
that
ma'am.
correct? So that would mean, if there is 1 1 1 here, it would mean that this instruction is a register reference instruction if there is a 0 here, and if there is 1 1 1 here and there is 1 here, then it would mean that this is a IO instruction, right?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes,
And
ma'am.
what if this is not 111? It is any one of the 000 to 110 opcodes, then it would mean that it is a
Memory reference instruction.
memory reference instruction, right? So the next step, what we do is we decide upon what kind of instruction this is first of all. Okay, now if D7 is 1, then it is either a register reference or a IO instruction. ठीक है? And if it is 0, then it is a memory reference instruction. Now, if the D7 is 1, then I go out and look at the value of this I bit. Okay. Now, if this is 1, then as we had just seen, this would be a IO instruction, and if it is 0, then it would be a register instruction. Okay. In any case, nothing is to be done now. Please see in the next time signal, what we need to do is, if this is a register reference instruction, then the opcode has already been decoded. That means at this point, I already know what is to be done. Okay, so I go on to execute the register reference instruction. And after the execution of the register reference instruction, that is implied here, okay, that is implied by this opcode, I again set the sequence counter to 0. Okay, and the same goes for the IO instruction. So the instruction enters the execution phase T3 in time signal T3 if It is either a IO register or a IO instruction or a register reference instruction. Is this clear? Anything that is not clear in this pathway? This pathway of the flowchart is clear? This is clear, or fetch phase, decode phase, and this is clear,
Yes, ma'am.
right?
Yes,
Now,
ma'am.
what happens when D7 is not 1? That means it may be a memory reference. It is a memory reference instruction. Now, this memory reference instruction may be direct or indirect. Who will tell me? Again, the flip-flop I will tell me. So, if the flip-flop I has 0, then this is a direct memory reference instruction. If it is a 1, then this is a indirect memory reference instruction. If this is the indirect memory reference instruction, what do I have to do? I have to go back to the memory and fetch the effective address, right? Yes or no?
Yes, ma'am.
Right. Now, this phase is known as the indirect phase. This phase is known as the indirect phase. So in T3, in case this is a memory reference instruction, in the time signal T3, we go back to the memory, add the address which is there in the address register, okay, and we get its contents. What those contents would be? In this case, the contents would be the effective address, and put them back into the address register. So that after this step, the address register now contains the actual effective address of the operand. So that now it has the location of the operand, and it can start executing the instruction in the next phase. In the next phase. Is this clear?
Yes,
Yes,
ma'am.
ma'am.
Right? And now suppose if the value in this I flip-flop was 0, meaning this was a direct memory reference instruction. In that case, did we have to do anything in the indirect phase? Do
No,
we have
ma'am.
to do anything in the indirect phase? No, right? We don't have to do anything in the indirect phase then. So in time signal T4, okay, whether it was a direct memory reference instruction or a indirect memory reference instruction, in time signal T4, we proceed towards execution of the memory reference instruction. Is this clear? Is this
Yes,
clear?
ma'am.
Now, how these instructions are actually executed, we will see. Okay, we will see in the next class. Okay,
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 so
ma'am.
ma'am.
after this, after execution of each of these instructions is done, you see that the sequence counter is set back to 0 again. Okay, and we go back here. Why? This is because this is so that we can again start from the time signal T0 for the next instruction cycle. Okay, to execute the next instruction. Is this clear to everybody?
Yes, ma'am.
Yes, ma'am.
Now, one more thing which is to be noticed here is that because the memory reference instructions can involve indirection, right? This step, right? Where we need to go to the memory again. That is why they are longer than the register reference and IO instructions. So it amounts to saying that IO instructions and register reference instructions are faster than the memory reference instructions. Okay, sometimes you are asked how many memory references are required to process an indirect memory reference instruction. Will somebody like to answer that?
Can you please repeat the question?
Yeah. So, how many memory references are required to execute an indirect memory reference instruction vis-a-vis the IO instruction or vis-a-vis the register reference instruction or vis-a-vis the direct memory reference instruction as compared to any of these.
And two.
Please see, yeah, please see all other kinds of instructions just require one memory access. You're looking at this memory access step here. Yes, this is the only time that we have gone to the memory. We have accessed the memory in this entire flowchart, right? But if it is a indirect memory reference instruction, then we have to do it for a second time again. Okay,
Yes, ma'am.
right? So next time we are going to be looking at the execution of the register reference instructions, the IO instructions, the memory reference instructions. Okay, and accordingly, I'll tell you how to start executing these instructions in the CPU sim. Okay. Any problem in today's class?